Hello, welcome to Tech Transform. In my couple of last sessions, we have already seen a lot of Spark RDD programs in order to find different solutions of a problem. So here we are going to find out the more interesting problem, and we are going to find out the solution using Spark RDD. In this session, I'm going to cover find the most popular superhero in a social graph. So let's say you have a social graph like this of superheroes, and in a comics, let's say Hulk is connected with Spider-Man, or Hulk is connected with Thor. Hulk is connected with Thor. Hulk is also connected with Iron Man. Also, you can say Thor is connected with Spider-Man. Thor is again connected with Iron Man. So these are the social networks of superhero. The data is already there, and we have to find out uh, who is the most popular superhero amongst all. Means there could be a relationship of a single superhero is connected to n number of superheroes. So for each we have a data how many each superhero is connected to how many superheroes. Those having the most superhero connections, those having the most connections with the others, is going to win the race and going to become the superhero, most popular superhero in a social network. So let's uh, I want to quickly introduce my data set. So today the data set is two data sets, Marvel Graph and Marvel Names. So Marvel Graph is the actual data where having where we have having the each superhero and his connections, and this is the lookup, means a hero ID with the name lookup. So let's see how it looks like. Okay, so this you can treat as a superhero ID, and this superhero is connected with this much superhero IDs. So IDs are given here. This superhero is connected with this much of superheroes. There could be a chance that in another row this is also going to again repeat, and finally we have to find out, okay, let's say for this superhero, what is the number of count of the connections, what is the number of count of the connection. It could be chance it is going to repeat also. So finally we are going to apply reduce by key, and let's see how this name lookups look. So this you can see each superhero ID, here the name is represent which ID is representing which name. So we have 4000 something, around 19,428 superheroes with ID and name. So we are finally I'm going to connect this superhero name and with this Marvel graph.txt, and finally look up, and finally we'll find out the actual superhero name, not the ID. For this entire problem I have already written in Spark program. Let me quickly open that and we'll go one by one. So this is the Spark driver program I have written, that is most popular superhero. And here what I have done, here I have imported some of the basic packages: Spark Context, Log4j, and Scala.io also. These are the two methods we are going to see later why I have written this. These are user defined methods. This is our main method. These are normal in order to suppress the unwanted errors. I have created then a Spark context. Then I am actually first I am building a hero ID name lookup. Hero ID name RDD means hero ID will be the ID, and the name will be I am going to create a RDD of hero ID map to name. Hero ID map to name. For this, what I am doing, this is the very first thing I am doing. Where names, I am creating a RDD where I am loading the data from Marvel names.txt. This one. So based upon this, I am going to create a RDD of hero ID with name. So if you can closely look the data, so how the data looks like. So data is like movie ID, then a space, then the inside the quotes the name is here. So here you can't say that this is this separated with this file is separated with a space or quotation marks. So but we can cheat here and we can find out. Let's say if I want to separate this file, separate this line based upon split this line based upon this quotation. So what we are, if we are split based upon this quotation, what we are going to get, we are going to get this first as a field, means id is id and id and a space, then the actual movie name. So we are going to get two fields if we are going to split based upon quotation. So our main purpose is we get the id and get the name and map and create an RDD. For that I have created, I am applying flat map. Why flat map? Because some of the IDs, let's say we have the ID but we don't have the name, like that. If we have a ID but we don't have the proper quotation marks associated with that, so for that we have to deal with those edge cases also. We have to handle null also. For handling null, because if there is a null data and all those, we cannot use map. It's because map is, if you're creating, if you're resulting out, RDD is also having one-to-one relationship, but here we are not sure. We could have that two or n number of RDDs in a row can result into n minus 1 or n minus 2, something like that. So we can use, we are using flat map here, and I've created a user defined method called parse names. What it is doing, it is going to take this each line at a time. Okay, so let me expand this parse names. So this is going to take each line and resulting in an option of int comma string. Option is a I haven't discussed before this option. This option object in Scala is basically Scala doesn't provide any null value handling or anything like in other programs. We can handle nulls. So in Scala, if we want to handle null data, we can use option, because option will give you an option to return, and sum means we have some data or we have no data. That's why we are using, because in some cases we are going to actually have a data, we don't have a data. In some cases if we have a ID but we don't have name, so we are not going to return anything because we don't have name there. For that we are going to return none for that. So for returning none or for returning some means we have values and we don't have values. For that, what we are doing here, we are creating an option object. So option object will give you a flexibility to handle null data in your data set. So now the next line, what I am doing, I am splitting the each line based upon this quotation. So based upon this quotation, based upon this, then I am checking whether I am, means my field dot length is greater than 1, means we have ID and name also. If both are there, then I am going to return that value, otherwise I am going to return none. For that, sum resulting in sum object, and the first value would be what? Fields 0. Fields 0 means this value, ID followed by space. Then we have to remove this space, then I am doing trim and to int converted into integer. So this is the hero ID, and this will give me the hero name, fields 1. So this will finally construct a hero ID name pair and return. If there is no name found or some unwanted or not correct data, we are going to return none. Okay, so up to this we have done. Now we have names RDD. Now let's load the actual superhero co-appearance data, means this data. We are loading into RDD first. So this is the file, path of the file. Okay, then what we are doing, we are converting into hero ID into number of occurrences, because this hero, finally we have to find out the count of this association, count of these occurrences. So what we are doing, finally we are converting, we have to convert hero ID and number of connections. Okay, for that I have written a method called count co-occurrences. How does it looks like? Let me expand that. So this is the method. So this method is going to take each line at a 1. Okay, and I am splitting based upon regex. What regex will do? This means double backslash means this is we are going to split based upon a regular expression, and this is nothing. S plus means we are going to split based upon a space. Okay, So if we split based upon space, we have this resultant RDD containing this much all the IDs. So what we are going to finally return, we are going to return a tuple of hero ID, means first element 0.2 first means hero ID, then the elements dot length will give you total length of each line. So it will give you total items inside this line, length will give you, and we are subtracting 1 because we don't want to count this superhero ID. So this is the main superhero ID and these are the connections. So finally we got superhero ID and what is the number of occurrences, what are the number of connections he has. So this is the pairing RDD, hero ID and number of connections. Then finally I am going to combine, because there could be a chance the same hero ID can be occur in the next row also. So I am taking help of reduce by key, and for the same key, for the same hero ID, I am adding all the occurrences. Finally I will get total friends by character. So how many, so this 5988, how many friends he has. Okay, then I am flipping this because this contains hero ID comma connection. I am flipping it and making connections comma hero ID. Why? Because I want to finally apply the max, and max is going to apply on the key. So key I want to make right now, key is hero ID and connections. I want to make connections as a key and hero ID as a value. Why? Because I am going to apply max and we have to find out the number of most popular. So we are going to apply max on number of connection, not max on superhero ID. So that's why I am flipping this and making this as a key, count as a key, and value as a hero ID as a value. So we can apply max. So this flipped becomes connections ID, hero ID, we applied max, so it will give us, finally it is going to give us the superhero which is having maximum connections. Okay, so now we have finally we have the maximum superhero comma superhero ID. So we don't need superhero ID, we are going to replace with the actual superhero name. For what we are doing, we have created a names RDD, this one, names RDD. It's containing integer and hero ID and mapping with the name. So we are applying lookup to this names RDD and try to find out for each hero ID, means in flipped one the hero ID is at second, the hero ID as the hero ID tuple is the hero ID is at second item in a tuple. So I am passing this hero ID and looking up in the names RDD and getting the value. So this is going to return a lot of value, so I'm going to get first one because we want the names. Okay, look up the name, lookup returns an array of results, so we need to access the first result with 0. So this will going to give us a, because this, why it is going to give us a list of result, because this can be the same ID can, there could be a chance the same ID is going to repeat in a number of other rows also in this tuple. Okay, so we want, if we want, although it is going to represent the same ID same name again and again, but we want one name. Why? Due to that I am just taking the first item in an array, then I am printing the value in a user defined way. How? Println then most popular name. So I am printing the actual most popular name from here, is the most popular hero with most popular this dot underscore 1, means this will be the count, the first well will be the count, the co-appearances. We can say the most popular hero name means any name is the most popular with how many connections we can print finally. So let me quickly run this example. For that, let's go and create a run configuration. I have already created that run configurations. So this is my run configuration. I have given a name most popular superhero, and main class is, project name is Spark Core. Main class is spark.core.most popular hero. Then hit on run. So it's finally printed that Captain America is the most popular superhero with 1933 co-appearances. Means it has 1933 connections with other superheroes. So Captain America is winning here, and it is becoming the most popular superhero among the social network graph of the superheroes. So that's all for this video. Thanks for watching. Have a good day. Bye.